Okay, so I thought I was going to only make 2 videos for section 2.8, but I made a mistake. So this is the 3rd video for section 2.8, and we're still dealing with composition. So if you'll go down, we've only done 2 examples, I think, in composition. Yeah, example 5 of part A and part B. So let's go to example number 6. These are more generic. Notice that I'm looking here at f of g of x and its domain, whereas the previous example, I was looking at f of g of a number or g of f of a number. So this is a more generic concept. So let's go find f of g first. And the first thing that we're going to do here is rewrite it in a nicer form. So we have f of g of x. Since we know what g of x is, let's go ahead and plug it in. Just substitute. So you notice these two are the exact same thing. They're equal to each other, so we can substitute one in for the other. And now what I'm looking at is I want to take 2 over x, and every single time I see an x in my f function, I'm going to replace all of those x's with 2 over x, because this says f of 2 over x. All right, so you'll notice here that that's what I've done. This x got replaced with 2 over x. And then the plus 4 just got copied. All right, now from here on out to the end of this question, not the domain part, but just to the end we get the answer, this is all just cleanup. You're finished with the composition. You took one function and you plugged it into another function. The rest of it is pure cleanup. So the first part of that is let's get a common denominator. And then notice that we've got our common denominator here. On top was our 2 plus 4x, so that's what you see here. This is where I'm rationalizing the denominator. Remember, you're not allowed to have a square root in the denominator. So we multiply by root x over root x. Now, what I did on top is maybe a little different. You might want to just go ahead and multiply the tops by distribution. So take that x and distribute it to the 2 terms. Remember, you're allowed to multiply insides and insides. I didn't do that. What I did was, let me show you here. I noticed that there was a GCF, and so I factored out the GCF. This x is what I already had right here. Okay, that's totally legal to do. It's fine. And then the next thing I did was I just rearranged the numerator. The 2 times the x, I wrote them beside each other. Notice that the bottom is not under the square root because the square root of x times the square root of x is just a plain old x. Okay? So you could have this as your answer, or quite frankly, you could also have 2x plus 4x squared inside the square root all over x. Either one of those would be just fine. Now let's talk about finding the domain. This one, I'm just going to tell you right up front, folks. This one's a little challenging to find domain, so stick with me. Be willing to pause, rewind the video, rewatch this part, because this one's a little bit tricky. So what we're going to do, first of all, remember that the domain is generically going to be all real numbers, except for 2 cases. We're looking for the case where I might have a 0 on bottom. Oh, well, that could happen here, 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 here. All of these could have 0 on bottom. And case 2 is where I have a square root. Oh, look, all of these have a square root. So I'm going to be dealing with both cases at the same time on this one. So that's what makes this one a little bit challenging. Let's deal with them one at a time, though. So the first case was where I have a 0. I could have a 0 on bottom. Remember that all we do is just simply take whatever our denominator is, make it not equal to 0. Okay, so this one's an easy one because I didn't even have to solve anything. I just say that the bottom, x, cannot equal 0. Okay, so no problem there. The second case is where I deal with square roots. Now, I want you to remember this particular one. Here, I have this guy. All of this was cleanup of that guy. So these are all the same thing. So just pick one of them, and I'm going to pick the one that looks the easiest, which quite frankly, in my opinion, is this one. And I'm going to say whatever the inside is not allowed to is not allowed to be negative. So whatever the inside is has to be positive. So I wrote the inside and I said, hey, the inside has to be a positive number, has to be greater than 0. It could be equal to 0 as well. Okay? And we'll talk about that in a minute when I put the two cases together. All right, so let's just solve. So the first thing that we'll do is we'll subtract the 4 on both sides. And then you can multiply by x on both sides. Divide by -4. Oh, don't forget, when you divide or multiply by a negative on both sides, remember that sign, that inequality has to switch. So I hope you didn't forget that. And then I'll reduce my fraction. When it comes to inequalities, I really like it when the variable is written first. So I'm going to change this to x is greater than or equal to -1/2. Now, let's put our two cases together. Let's look at what this is going to look like on the number line. So all of my x's greater than or equal to -1/2, that says that, hey, I can choose any number to the right of -1/2. But when I combine it with the fact that x is not allowed to equal 0, I have to throw out that particular value of x equals 0. So then what does that look like in interval notation? Well, the first piece is going to be this, sorry about that. The first piece is going to be from -1/2 up to 0. And the second piece is going to be from 0 all the way to positive infinity. Okay, so then this is what your, this right here is your domain. This is your domain. All right. Okay, let's do another one. And I might have messed up the domain on this one. We'll see when I uncover it what exactly happens on this one, but that's okay. We can figure that out. All right, and we'll fix it in the process. So the first thing that we want to do is we want to just rewrite it so it looks better. The second thing is we want to take our f of x, replace it with what we know f of x equals. And now I'm going to take and plug this guy into the g function. So everywhere I see an x in the g function, I'm going to plug in an x plus 4 inside the square root. Now, that's what I did right here. This is just rationalizing the denominator because we know we're not allowed to have a square root in the denominator. So then when I clean that up, on top, I'm going to have that 2 times the square root of x plus 4. And on bottom, I'm just going to have a plain old x plus 4. Now let's talk about the two parts of the domain. I think I've only got one part listed here, so we'll figure that out. And I'll write it down as we go. But I have, first of all, something that could make the bottom 0. So this guy could make the bottom 0. This guy could make the bottom 0. X plus 4 could make the bottom 0. So one of the things that I want to deal with here is that x plus 4 is not allowed, x plus 4 is not allowed to equal 0. That's one of the things that I'm going to be thinking about in my domain. The second thing that I want to think about in my domain is anything that deals with a square root. So I've got those here, and I have that here. And remember, whatever is inside the square root has to be, if inside the square root is x plus 4, has to be greater than or equal to 0. All right, now, when I put these two together, one of them says it can't equal 0, and one of them says it can equal 0. And so what we're going to say is, hey, it has to be positive, and it's not allowed to equal 0. So the best way to write that then is that my x plus 4 has to be greater than 0. It has to be positive. It's not allowed to equal 0. So that's the best way to write that then. And so we'll solve that little guy by subtracting 4 on both sides. So then In set builder notation, this says that x such that x is greater than -4. In interval notation, this is going to be from -4 to infinity, not including the -4. So like I said, I didn't write down both pieces, both cases, but I combined them basically into one case where I'm dealing with both cases at the same time. So again, how do you determine the domain? You just have to ask yourself about the cases. Do we have division by 0 possibly? And do we have an even root? Most commonly in this course, it's going to be square roots. All right, this time, example 7, this one's a little different. It says it gives me two functions, and it asks me once again to not only find the functions, but also to find the domains. Here we go. Write it nicely. Take g of x out, replace it with what it equals. Now let's take this guy and plug it in. Plug it in for all of the x's in the f function. So I have 5 over 2 over x plus 4. Let's get some common denominators going on here. Let's clean that up. So on bottom, I'll have 5 over 2 plus 4x over x. We know how to divide fractions. Remember that when we're dividing fractions, we want to multiply by the reciprocal. So we're going to have 5 times the reciprocal. And I like to think of this as a 5 over 1. So as I clean that up, then that's going to be a 5x on top and a 2 plus 4x on bottom. Okay. Now, as I'm looking for my domain on this one, case 1 deals with anything that could make the denominator 0. Well, I could have a denominator of 0 here, 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 and here. And notice now some of those are different. So let's start off with the easy ones, these guys. What makes the denominator 0 there? It's just simply x is not allowed to be 0. The one that's not as easy is these two down here. But again, my denominator is not allowed to equal 0. So let's solve both of these. Well, the first one is already solved. No big deal there. To solve the second one, you'll want to subtract 2 and divide 4. And so that means that x is not allowed to equal -1/2. So if you think about on the number line what this looks like, well, you've got two numbers you can't equal. You can't have the -1/2. You can't have the 0. You're not allowed to equal either of these two things. But you can have anything else on the number line that you want. So you can have from -infinity all the way up to -1/2. You can have between those two, and you can have after 0. So in interval form, that's what that would look like. Let's go look at part B. So for part B, we're going a different direction. So let's find g of f of x. So first of all, let's take f of x out. Let's replace it with what it equals. And now let's take that and plug it into the g function. We'll want to multiply by the reciprocal. Clean it up. And you could leave it as a factored form, or you could also say that on the top that's a 2x plus 8. Either one is okay. Now looking for the denominator, notice that I did have a denominator here that could be 0 and here. Once I got down here, these denominators cannot equal 0, but I do need to consider these up here. So x plus 4, the denominator is not allowed to be 0. So x cannot equal -4. In set builder notation, you have x such that x is not equal to -4. All right, moving to example 8. This time it asks the directions ask for something a little different. It says, show that g of f is not the same thing as f of g. Show that these two are not equal to each other. All right, so the first thing is, let's go ahead and we got to find both of these. We need to find g of f and we need to find f of g. So let's start with the first one. And I went with f of g first. I have no idea why. I guess that's just the one that I decided to do first. So let's substitute whatever g of x is. And then we'll take that and plug it into the f function. And we'll clean that guy up. So distribute. If there's any like terms, combine them. Oh, let's go the other direction. The other direction is we want to find g of f of x. So let's take the f out, replace it with 2x minus 5. And now let's take that function and plug it into the g function. So you notice I have, oh, I messed up. All right, so let's fix that as we go. Notice that I should have a 3x squared, and I did not write that, plus an x. Okay, so what I'm going to uncover then is I'm going to have to undo all of this because I did that incorrectly. All right, so we'll fix that. And we're following our order of operations, so we'll need to FOIL first. So as I FOIL, this is going to be a 4x squared minus a 20x plus a 25. Okay, so that's FOILed and my like terms are combined. I did it all at the same time. Plus 2x minus 5. Distribute your 3, so that'll be a 12x squared minus a 60x plus a 75 plus a 2x minus a 5. And let's combine like terms. So we have a 12x squared minus a 58x plus a 70. All right, and we can see there then that these guys are not equal to each other. So see, even the teacher makes mistakes. All right, number 9, find functions that form a given composite. So what this one is it's a work backwards question. You'll notice that I'm told that f of g looks like this. We're asked to find what f of x is and what g of x is. Now, there's one that's an obvious answer, and then there are others that could also be answers. They could also work. And so there are multiple things here that could work. But the way I see it is that this kind of looks like a 4 something squared minus a 5 times the same thing minus an 8. That's kind of what I'm seeing. And so I say, hey, the g of x, the one that's on the inside, is 3x plus 2. It's this guy. And then the f of x is the one that's on the outside. So you've got a 4x squared plus minus a 5x minus an 8. So essentially I would be taking this 3x minus 2 and I would be plugging it in for this x and this x. That's not the only answer to this one, but it's probably the easiest answer. And that wraps up all of section 2.8.